This problem came from 2017 AP Physics 1, and the problem states a student wants to determine the coefficient of static friction between a long flat wood board and a small wood block. Describe an experiment for determining the coefficient of static friction between the wood board and the wood block. Assume equipment usually found in the school physics lab is available, and draw a diagram of the experimental setup of the board and block. In your diagram, include each quantity that would be measured and draw or state what equipment would be used to determine each quantity. And then they say describe the overall procedure to be used, including any steps necessary to reduce experimental uncertainty. Give enough details so that another student could replicate the experiment. So if you have a board and a block and you want to determine the static friction, you probably would have some setup where you have a board with under that angle with the surface. So you would have to determine, you will have to change the angle. So depending on the angle, so here I'm going to call the angle theta, and here is the block. And so when you, and they ask you to write down everything that is given. So you would have, this is the block, this is the board, and angle, inclined angle, the one that you will measure. Depending on this angle, you will determine when the block starts sliding, and you need a protractor to determine the angle. And you have the floor, the table, or the surface. And so this would be the diagram that they ask you to draw. And then for your own work, I would write this. So here is the board, here is the block, and I'm gonna write the forces acting on the block. So I have the force of gravity, so here is mg. Then I have the normal force present, and then there is gonna be the static friction. So I'm gonna call it the lowercase f for the static friction. And I'm gonna choose my axis, x and y, along this sliding part. So here is my y, here is my x. Because if the block starts moving, then acceleration is gonna be along the x-axis. So I need to place my components. If they ever ask you to write the forces acting on the object, these are the only forces. You know, don't ever place the x and y components of the vectors that don't match the axis. But my mg is not aligned with y or x axis, so I need to align the y axis and x axis components of mg, and this will be the angle theta. So if this was angle theta, then this part is going to be angle theta. Let me show you why. So if this is the force mg, and if this angle was theta, then if I place a line that is perpendicular to the surface, to where the board would be, so here is the board. If this is the right angle, then that one is the right angle. So if this was theta, then this one is 90 degrees minus theta. Then this one is 90 degree, then this part must be theta, or theta and theta. Also, something interesting to notice when you do these inclined planes, if this is your angle theta, then if this is my y and this is my x, and this is, let's call this one is force. So if this was the force, so let's say the force is pointing this way. So if the force at this point is pointing that way, then this will become the y component, this will become the x component. And from here, I can write the sine of theta is equal to y over f, and the cosine of theta is equal to x over f. Now, I can write that x is equal to f cosine theta, and y is equal to f sine theta. And also, something interesting to notice, if the side of a right triangle is adjacent to the angle, then it will be f cosine theta, or hypotenuse times cosine. And if the component of the force is opposite of the angle, then it will be that hypotenuse sine of theta. So looking at this graph, which is the green part of my drawing, I see that I can measure the static friction. I can raise the angle of on the incline. I can raise the angle until my block starts sliding. When my block starts sliding, I can stop and use protractor to measure the angle. So I need to find an angle at which my block is gonna start sliding. Right at that moment, I have to measure that angle, and I'm gonna use it to do my calculations for the static friction. And my block will be in equilibrium and not slide for as long as the force of gravity, the horizontal part of the component, let me do it maybe in dark, here it is. So as long as this part, which is mg sine theta, is equal to the friction force. So if the friction force is greater or equal to mg sine theta, the block will not slide. As soon as the friction force less than mg sine theta, the block is gonna start sliding. Also, the friction force has the formula of mu times n, the coefficient of friction, times the normal force. And the normal force must be equal to the vertical part of mg, which is mg cosine theta, because it is adjacent to the angle. So this one in the one that I'm going to draw in blue. So the vertical component, it must be equal to the normal force, and because it is adjacent to the angle theta, it's called mg cosine. So the friction force will be equal to mu times n, and n must be equal to mg cosine theta. So that is going to be mg cosine theta. So if I plug this into my equation, then I have mu mg cosine theta must be greater or equal to mg sine theta. If I cancel mg and mg from both sides, then I will have that mu must be greater or equal to sine theta over cosine theta, or I can write it as tangent theta. So all I have to do is to figure out the angle at which my block is going to be sliding and take the tangent of that angle. So the only measurements I have to do for finding the coefficient of friction is the angle. I don't need the mass, because the coefficient of friction does not depend on the mass or acceleration due to gravity. It only depends on the angle in the two surfaces that are in contact. Also, for every experiment that you do, you have to do a few experiments. In every experiment you will do, you will have to have the same block and the same incline, and probably the same protractor. So there will be less error for every measurement that you're doing. So you will want to repeat a few measurements for block sliding and then you can even take the average of all the angles that you find for those calculations or measurements. So it's going to be somewhere the closest angle that you can have. So for B part, they say find the equation for the coefficient of static friction in terms of quantities measured in the procedure from part A, and we found that theta must be greater or equal to the tangent of the theta angle that we measured. And because AP exam is graded by the rubric and they give the points for every step that you do, when you answer again these type of questions, you want to write all the steps. So in this case, you would write the sum of all the forces must be equal to MA, or the net force is equal to A. And in this case, because the block is not going to be moving for static friction, your acceleration must be equal to 0. So the sum of all the forces must be equal to 0 for the equilibrium. And then when you do the sum of all the forces equal 0 for equilibrium, you have the equilibrium on the y-axis and you have the equilibrium on x-axis. And on the y-axis, you have two forces. It's the normal force pointing up and a negative force pointing down, which is mg cosine theta. And because they're balanced, their acceleration is equal to 0. For the horizontal forces, because remember we chose the y-axis to be this way and the x-axis to be this way, so here is x and here is y. You don't have to write it down, but it's just for our reference. And then for the x-axis, I have the force of friction is, if I choose up to be positive direction, then down direction is going to be negative, which is mg sine theta. And that is also equals to 0 if it is balanced. So from here, I have that the normal force is equal to mg cosine theta. And I know that the formula for the friction is mu times n. So now that I know that what my n is equal to, instead of friction force, I can plug in mu, and n is mg cosine theta, and then move mg sine theta to the other side, and I have mg sine theta. So, and then after this step, I can cancel mg from both sides, and I get, let me make it a little bit darker, so mg from both sides, and then I will get mu is equal to tangent of theta. Or in other words, because your friction force must be greater or equal to, in order not to slide down, then the mu must be greater or equal to the tangent of that angle that you're going to be measuring. So for every step that you do on AP exam, you get a point. So don't skip the steps. It's very important to write everything you know. And you can also measure, you can also mention here that this is Newton's second law. The sum of the forces equals to ma, or the net force is equal to ma. And this symbol means the sum of all the forces. For the next part of the question, they said that a physics class consisting of 6 lab groups wants to test the hypothesis that the coefficient of static friction between the board and the block equals the coefficient of kinetic friction between the board and the block. Each group determines the coefficient of kinetic and static friction between the board and the block. The group's results are shown below, with the class averages indicating in the below error. So here we see the average in the table. And then they say, based on the data, what conclusion should the students make about the hypothesis that the coefficient of static friction are equal, or are they equal? And so we have the static friction and kinetic friction equal to each other, they are not equal, and briefly justify your reasoning. So when I look at the data, I see some consistency. I have 0.54 for coefficient of static friction, 0.52, 0.56, 0.55, 0.54, and then the same I see consistency for 0.45, 0.46, 0.42, 0.43, and 0.44. So there's 6 groups. Looks like group 5 has some inconsistency. If they were using the same block in the same incline plane, they should not be getting these numbers. So for some reason, their numbers are not aligned with the other groups. So I cannot trust their average values, so I cannot look at their average values. But I can look at the other groups' numbers and try to calculate their average. And if I do calculate their average without group 5, then I will get different numbers. So I get 2 different numbers if I don't use the outliers from the group 5. I get these 2 numbers for the average, and I see that they are not equal to each other and should not be equal to each other. So I say they're not equal to each other. If the coefficient of static friction and kinetic friction, the difference between two, if you are not sure what it is, so the difference is this: static is not motion means, and kinetic is motion. So if there is sliding present, then kinetic friction is involved. So if the block is sliding down with some velocity, doesn't matter constant or not, if it's sliding down, if you sliding down on the floor, then you have kinetic friction. It's the friction of motion, like kinema. But for static friction, it's when the block is not moving. The block is the static friction is stronger than the kinetic friction. When the static friction cannot hold anymore, the block starts sliding, and then you use coefficient of kinetic friction for your calculations. So coefficients of kinetic and static friction cannot be equal to each other. And so again, if I eliminate the outliers in my data, then I get them to be different. And for the last problem in this question, they say a metal disc is glued to the top of the wood block. The mass of the block disc system is twice the mass of the original block. Does the coefficient of static friction between the bottom and of the block and the board increase, decrease, or remain the same? And if you remember, we had these calculations earlier. We had this written earlier, and then we replaced the friction force with mu times n. So we had mg sine theta is equal to mu mg cosine theta. And when mg and mg canceled, we had mu was equal to tangent theta. So if I add another block on the top of the existing block and make the mass of the block bigger, you see that the masses cancel anyways. So the coefficient of friction does not depend on the mass of the block. It will depend on the surface or the material of the wooden block and on the wooden plank that we're using. So it only depends on the material in contact and on the angle that we were changing and calculating or measuring for different angles to find that coefficient of friction. And that is all I have for 2017 AP Physics 1 FRQ exam. If you like the video and if it was helpful, go ahead and like it, subscribe, and I hope I see you in my future videos.